Hi guys, I'm Archit and I'm making an informational tutorial on how to make load balancers on AWS. This is going to be a three-part series in which I'm going to introduce how to make a classical load balancer, an application load balancer, and a network load balancer. Let me start. I'm using an Educate account here, so I won't be able to demonstrate using paid services, but you will definitely get an idea of how you can create load balancers on your own. So in the first, I will start with creating an instance for the load balancers. These two instances I had created earlier for testing. Now I'll be creating new two instances for which in the first step, I will have to select the AMI that we have to choose, which supplies the software configuration for a virtual machine for us. So basically over here in the Amazon Linux 2 AMI, we'll be getting the software configuration of 64-bit x86, which is a free eligible AMI that is available in my account. Next, after selecting this, I will have to select the type of instance that I have to create. Say, for example, over here, I will be selecting the T2 micro instance type, which gives us 1 GB of memory for the applications to load. Next, in the step, we have to configure the instance details. And here I will be giving two instances that I have to make. Next, I will be using the default VPC virtual private cloud that is already there in the account. Next, in the subnets, what I can do is I can select an availability zone in the region, North Virginia, that I've selected. But when I keep it default, no preference, it will be automatically selected for the instance that has to be assigned to an availability zone. Next, I will have to change the IAM role to default. For the next settings, I'll be keeping the settings the same. You can review and change according to how you want. Next, in the storage that I have to add to the instance, here it's a predefined storage that is giving us, which is a general purpose SSD of size 8 GB. In the next step, I can add tags. You can add a key pair. So for example, it's a name and the value is, say, for example, instance ARC, my first three letters of my name. Next, in the security group, I will have to add HTTP to make sure that it is available to anyone who has the access to the link. Over here, we can see that port 80 is the default port for the HTTP security group. Over here, we can see that the HTTP group comes with both configurations of IPv4 and IPv6. Next step, I will review and launch. For here, we get all the settings that we had given to create the instances. We can review them and click on launch. Now, before launching, we will have to create a new pair, create a new key pair. So I will create a new key pair and I will name it key pair and my name. This is a very critical step to load the instance to the HTTP port, and you have to make sure that you download the key pair before proceeding with the launching of instances. Here you can see that the file pem.pem file has been downloaded with my name that I had given to the key pair. I will click on launch instances. Now we can see that your instances are now launching and we can view the instances. Now we can also give name to the instances. So for example, instance 2. And for this one, I will give, say, instance 1. Okay, now we have two instances that have been launched, and now we can see both the instances that are here that have already been launched. Over here, we can see that the instance state of these instances are running, and we have to wait for the status check. And it is still initializing. We will have to wait until it becomes like all the checks have been passed. Next, we can see that the status check of both the instances have been 2 by 2 checks passed. This took some time to be done, I think around 2 to 4 minutes. And it depends on each server. That is not an issue. So over here, now that both the instances are up and running perfectly, we will what we will have to do is, and we will have to connect these instances to the HTTP server. And for that, we will have to copy the SSH address from the SSH client of each instance and go to details. Now over here, to connect the instance to the HTTP server, we will go to the connect button. And over here in the SSH client, we will copy the public DNS. After copying, we will have to go to the command prompt and change the directory to where my PEM file was downloaded. After going to that file, what I will have to do is write a few commands, which I'll be following right now. The commands, first I will have to give the public DNS to connect of the instance to connect it to the HTTP server. Now I will write SSH-I and give my file name, which is keypair underscore Archit .pem. And I will paste the DNS that I had copied from earlier. Now it's asking for permission. I will say yes. Now I will have to do sudo su. So over here, we will have to copy this line. And after copying, we go to the command prompt. And in the command prompt, we have to paste the line. And the next line that we have to do is sudo su. After writing sudo su, what you have to do, the next step that you have to do is yum update -y. So this will update the yum. Take some time, as there are 29 other libraries that are present over here. It's almost done. The next step that we have to do is we will have to install HTTPD using yum. So we'll write yum install -y HTTPD. This is done. Now we will have to do system CTL, basically system control, start the HTTPD. And next we will have to write system control again and enable HTTPD. So with this, what will happen is our HTTP port will be enabled. And now our using the SSH command that we had written in the start, this command, what we are doing is we are connecting the key pair of the instance to the HTTPD server over here. Now both these are connected. Now the next step that I have to do is I have to give something to the application, basically content to the application. Okay, so I will just write a small HTML code over here. So I will write Archit's first instance and close the h1 tag. Also, before that, we will have to give the word echo. Echo basically means print, to print something. So we'll do this and we'll give so over here, basically we can understand as I am giving this content of this, the content that I have written over here to index.html. Okay. So now over here, what we can do is I can check how this is working. See over here, we have the public IPv4 address. We can access this instance, the application that is there on this instance using this IPv4 address. We will open this inside another tab. Let it load for a few seconds. See, but here for some reason it is not being able to connect. So basically over here, what we have to do is in the instance, when we go to connect, over here in the EC2 instance connect, this is the public IP address. We have to copy this and we will say paste. Also, by the time I have changed the echo that I have done in the command prompt, I have changed a little. And next, what I have to do is I go to this and I check. So I'm getting this is my first instance. Now I have to go over here. I have to do exit. Again, exit. Wait. Exit with a colon. So I have to just write exit and colon. I'm out. Now I have to do the same thing for my second instance. We'll go to the instances. We'll open the second instance. And we will want to connect this instance also to the HTTP server. Go to the SSH client, copy the code over here. As we're already in the download, we don't need to change the directory. I will give the SSH command, say yes, grant permission. Now my EC2 is active. I will do sudo yum update. Now it will update all the packages. So yes, I think it will take some time for all the libraries to update again. Sometimes it happens that we will have to update this again and again to make sure that we are not losing anything, not losing any library to perform our application. I'll do sudo su yum update y. Oh, sorry, yum update y. Yeah, see, As we are updated already, it says no packages marked for update, which means that we have already updated everything. Next, we will do yum install -y httpd. Sorry, httpd. All the packages will be downloaded over here. And next, what we have to do is systemctl. You have to start httpd, and then we have to systemctl enable httpd. Next, we will have to again write echo say my. Now I will write something else just to identify that it's a different instance. I will write this is Archit's second instance. Okay, close the h1 tag, close the quotes, close the bracket once again, and write var/www dot, okay, slash again html/index.html. I have echoed this over here. So which means I have put this line, the HTML code, to this instance. Next, how to check? We'll go to EC2 instance connect, copy the public IP address over here, and enter in a new tab. See, this is the HTML tag that I had given. So now this is my first instance, which is saying this is my first instance, and this is my second instance, which is showing this is Archit's second instance. So basically, we can see that these are two separate instances. Now for the main part, what we will have to do is we have to create the classical load balancer. So over here in the EC2 instance service, we have to go down, go to load balancing and select on load balancers. In this service, we will see all the load balancers that we might have created over here. So what we have to do is we have to create a new load balancer. So over here, we can see there are three new types of load balancers that are there. One is a gateway load balancer, which is newly introduced. Another is a network load balancer and an application load balancer, two of which we are going to do after this video. And over here, this is the previous generation classical load balancer. That is what we are trying to learn today. See, it also says that AWS will be retiring the EC2 Classic platform on 15th of August 2022. Basically, classical load balancers won't be a part of load balancers anymore. Over here, we will have to define the security groups to the load balancers. Before that, I will write a name, say classic O. Okay, I will have to just log in once again. So actually, after logging in once again, the instances were stopped automatically. I just restarted them. I will reconnect them once again, and then we will resume our work. So over here, after reconnecting, only the IP address of the instances to access the public IP was changed. Other than that, it was already, the applications were already loaded to the instance. Now, next, we were doing the load balancers to create the load balancers. We will create a load balancer, the classic one. Over here, we will give classic load balancer for Archit. I will again choose the default VPC. And we'll give the STD port itself for the load balancer as we want it to be publicly available over here. Security groups, there are a lot of security groups, but we are going to choose the one with the default VPC security group, or we can also create a new one. So basically quick create Archit, and it will be with HTTP. So we will just create a new security group. Oh, it was quick create Archit. And over here, the protocol that we're going to choose for this is going to be HTTP, obviously, which is our goal. The port of the HTTP group is obviously 80. And over here, we're going to keep the IP address as the only IPv4. Next, we go to security settings and to check the health checks of the load balancer. So basically understand what settings we have given over there. Okay. And the next step, what we have to do. So basically over here, we can say response timeout. So for example, whenever a user will try to open the application using the IPv4 address, it will take 5 seconds for each instance to jump from one to the other, and interval is for 30 seconds. Next, in the next step, we are going to add the EC2 instances. Basically, connect both the EC2 instances that we had created. We'll select both of these, and we'll go to the next step. We can create a tag. It's not compulsory. We can just review and create. Yes. So basically, these are all the settings that we had given earlier while creating the classical load balancer, and we'll click on create. We can, as you can see, the classical load balancer has successfully been created. We'll close this. Our classical load balancer is over here. We'll go check the description of whatever settings that has been created with this. So over here, we can see the basic configuration of the classical load balancer that we have created as it is selected. And over here, we can see the instances that are present inside the load balancer, the availability zones that are present for the load balancer to jump, the health check, the migration. Okay, now what to check if the load balancer is working perfectly or not? We have to copy the DNS name. We have to go to a new tab, paste the URL over here, and check the URL if it is grabbing the instance or not. Now what should happen is if I refresh, so basically the interval time that we had given over there was 30 seconds. So sometimes it might take 30 seconds, sometimes it will not. So depending, so in the real world, if say for example, if one of the application is crashing or is not working properly, or one of the availability zones is failing where my instance any instances application is being stored, then the second instance or any other alternative instance will be fetched automatically. So see, every time I refresh this page, my applications are going to change, which basically means now in the real world, what we do is we give the same applications in all the instances. So whenever a user refreshes, they won't know if this application is being fetched from a different instance or a different availability zone. That's the best part over here. And I think with this, I have explained how we have to create a classical load balancer. This is a very basic, simple one, which is accessible to anyone in the World Wide Web, which has access to this particular URL. And that's it for now. I will come up with the second part in this series and show how to create an application load balancer. Thank you.